In this example, we'll be simplifying the trig expression you see on your screen right now. We have cosine squared theta times the difference between secant squared theta minus 1. Now, there's obviously many ways to do this problem. I mean, one way I'll talk out, I'm not going to do it this way, but yeah, I'm not going to do it this way because I do it this way in a different example. So yeah, one way you can do it is just take cosine squared theta and distribute. Cosine squared times secant squared. Well, in your mind, hopefully we know that secant squared theta is 1 over cosine squared theta. And when you multiply cosine squared theta by 1 over cosine squared theta, you get 1. And then that becomes cosine squared theta when you distribute it to the 1. And then you'll have 1 minus cosine squared theta, and I hope we all know what that equals inside and out, up, down, left, right, any day of the week, right? So I'll just be spicing it up and doing it a little bit differently since, like I said, I do another example in this playlist using that technique. So let's switch it up, drop my pen. So I have another one right here. Here's our example. Now, if we know our Pythagorean identities very well, then we should know that one of our Pythagorean identities, when we start with the classic sine squared theta plus cosine squared theta equals 1 and divide everything by cosine squared theta, we get tan squared theta plus 1 equals secant squared theta. Now, if I subtract 1 to isolate tan squared theta, what do we end up with? Well, glad you asked. And I have that on a card right over here. Given tan squared theta plus 1 is secant squared theta, isolate tan squared theta, then factor. We don't need the factor part for this example, but to isolate it, we would subtract 1 from both sides. So here's my little flashcard, and I definitely suggest you doing flashcards as well. That gives us tan squared theta equals secant squared theta minus 1. If we needed to factor, it's a difference of squares, we would use conjugates, but we don't really need that right now. But that all being said, what can I replace secant squared theta minus 1 with? Well, I'm glad you asked. That right there can be swapped out and replaced with tan squared theta. Now, I'm a big fan of panic mode. Panic mode is where we rewrite everything using only sines and cosines. We limit our ingredients so that we can easily see what can be combined, simplified, reduced, whatever. So I'm going to rewrite tan, or tan squared theta, with only sines and cosines. If I use my quotient identity, T, tan, has S on top. They're neighbors in the alphabet. Cotangent has C on top. They're the same letter, right? So I'm going to write sine squared theta over cosine squared theta. Now, what happens next? This cosine squared theta is really over 1. Anything on top and bottom, when you're all connected with multiplication, division only, no addition, no subtraction, we're allowed to reduce anything from the numerator with anything from the denominator. Okay, we have no equal signs, no plus signs, no minus signs, none of that nonsense. Adios, right? And what's left behind? Well, sine squared theta, and that is all. So hopefully you were able to follow and you think that example is beautiful, wonderful, easy, and I'm happy for you if you do. If you get it, got it, are able to do it, thumbs up. If you don't got it, get it, don't understand, can't do it on your own, put a thumbs down. And this way I know what kind of examples you definitely need more practice with, okay? So check out the playlist or the next video, and I hope you are getting smarter by the video. Bye.